Good day everyone. We have here the topic, the second law of thermodynamics about refrigerators. So, the second law of thermodynamics tells us that heat naturally flows from a hot body to a cold body. But is it actually possible that heat, an engine gets energy from a cold reservoir and transfer it to a hot reservoir? So, muna ang question sa ka-derive ng question sa second law of thermodynamics. So this law actually places fundamental limitations on the efficiency of an engine or a power plant. It also places limitation on minimum energy input needed to operate a refrigerator. So what is a refrigerator? Well, a refrigerator is basically a heat engine in reverse. An engine gets energy from a cold place and gives off to a warmer place. So refrigerator requires, of course, a net input of mechanical work. Next, for a refrigerator, the energy from a cold place is positive because reverse man ang ang engine sa refrigerator. So QC is positive, but the mechanical work and heat from a warmer place are negatives. So we have our law for cyclic process where the change of internal energy is equal to 0. So the total heat from a system minus work is equal to 0. Or QH plus QC minus W is equal to 0. Or by algebra we get QC as positive minus work is equal to negative QH. So in an absolute value for all these variables, we should not forget that the energy from a warmer place is always greater than the amount of heat energy in the colder place or in a cold reservoir. So we have here, let's compare a schematic diagram for heat engine. So we have here a schematic diagram for heat engine. So we have here, this is, and the arrows represents the directions of the energy flow. So we have here an energy from a hot reservoir, a temperature at a higher temperature. So nag-give up siya, padulong siya sa warmer place, tapos na siya yung work done. So whereas tapos there din sa refrigerator po, ato siyang ma-compare, ma-differentiate nga ang engine from an engine in refrigerator actually gets heat energy from a warmer place than to gets energy from a cold place to a warmer place, or the cold place is actually the inside of the refrigerator and the warmer place is the outside of the refrigerator plus the work done of the engine. So for best refrigerator cycle is that it removes a large amount of heat energy from a cold reservoir to have least expenditure of work. So we have there for better refrigerator when the absolute value of the heat energy from the cold reservoir over the mechanical work done is greater. So we have here the coefficient of performance. The coefficient of performance denotes that when you have higher value of coefficient of performance, the better the cycle, the better the engine of your refrigerator. We have here the coefficient of performance denoted by K is equal to the absolute value of both variables QC and the mechanical work, QC over the mechanical work, or it can be disassembled. The W here can also be disassembled as the absolute value of QH minus the absolute value of QC. So that's all for the refrigerator.